Just to kick off, I'm going to be the MC today. So you're all very welcome to this webinar on Passive House Easy, which we're starting to see lots and lots of chat around on LinkedIn. Indeed, I've had a few inquiries come my way as well. So just by way of introduction, my name is Barry McCarn, Vice Chair of the Passive House Association of Ireland. And today we're going to have a 45-minute session going into a little bit more granularity than the introduction session that we had hosted by Shane Kinsella from Mossart. And we're going to go through my own project as well. So Shane will talk more to that. That was the same project that was in the introduction of Passive House Easy. For those that have joined today and those that are maybe getting to the recording as well, we'll get you to maybe just follow the Q&A, and we'll pick up in real time Q&A at the end as well, and I'll dig that out as we go along. But by all means, you're very welcome to use the chat throughout the next 45 minutes as well, and we might tee up some questions then as well that are pertinent. So without further ado, I'll hand over to Shane, and Shane, you kick us off then, and we'll go from here.
Great, thank you very much, Barry, and good afternoon to everyone. So the aim of our workshop today here is to focus on, I suppose, the DesignPH export, and then calculating the TFA, and also the other, having a look at air tightness and stuff on the entries, and also the Vn50 entries into easyPH. I suppose I want to start this presentation by saying that I suppose there's an assumption here that everybody attending this has some knowledge of working with PHPP. I suppose if you're a beginner here in PHPP, this won't be a general PHPP workshop. So I will be glancing over certain aspects of it, because obviously we have a time limit, and I don't want to delay too long. So if you have any questions, anything like that, there's a Q&A box on your screen. Feel free to absolutely share anything that arises, and we'll do our best to answer all the queries. If you have a specific query, you can of course email me directly, or you can send an email to the Passive House Association, and they can bounce it on to me. So that's I suppose that'll get us going. So I suppose we won't delay. We'll crack on, because time is obviously limited here. So so I share my screen here. So if everybody can see that there now, so that is that PHPP that we're looking at in front of us here is Barry's house. It was a retrofitted dwelling, but it's done to Passive House standard. When I ran this initially in easyPH, what I found is actually we couldn't quite meet the criteria with easyPH, so I've taken some liberties just to update some of the stuff, Barry. So I'm not having a pop at your house here, Random, but it's with easyPH there's a slight difference here in how the calculation is done, and the weather files have also been updated. So there's no issue with that, any of that stuff, but I suppose it has been slightly adapted here. So so within the easyPH tab, I suppose we have a various set of inputs, and the tasks are laid out quite clearly in easyPH here. So through the various settings or through the various steps, we have project settings, U values, TFA, etc. As we work down, there's various sections. Each one has a note about what has to be done for that. So that will steer, I suppose, our work here, and how I suppose we carry out our modeling. So I suppose our first step is really to go to our DesignPH and get our building drawn up in DesignPH. So I have DesignPH open here, and this is the dwelling drawn in DesignPH here. I have a site map underlaid under that. I've drawn on the external or surrounding buildings, etc. One of the things that probably many of you guys who are familiar with doing the DesignPH will do is you'll calculate your TFA within DesignPH. There's actually no point in doing that in easyPH, because actually easyPH requires that we carry out the calculation within the easyPH tab. If you wish to draw it up in easyPH just for ease of measurement, that's up to yourself, but you're not required to set that as TFA. You will actually do all that locally within the easyPH software. But I suppose once you have your building drawn up, You can carry out all your normal processes here. You can input your U values. You can assign your window types, all that good stuff, all as normal. There's nothing unusual there. You can set your climate. In this case, I've used the Bell Mullet weather file for this example here. Actually, in practice, I've actually changed that, I think, to thinner, but it doesn't matter for the purposes of the example. So once you have all your DesignPH stuff done, you press your simulate button there to run your analysis. That will then simulate your analysis as normal. And then once you're completed that, then you need to carry out a geometry and components export. So we have to be very careful here. If we do a standard export, we upset the easyPH arrangement for how it's all put together in the software. So if you're starting from scratch here with these, you do a geometry and components export. So literally nothing unusual here. Click on it, select your project, you export your file. Nothing should be unusual there for anybody familiar with DesignPH. Again, as I said, I'm not going to go into the intricacies of DesignPH. That's I suppose a discussion for another day, and it would take up far too much time. But that's a basic overview of what you need to do for your easyPH. So once you have that done, then you carry out your export as normal using the Passive House Tools file. Click on your import, select your file that you want to import to, and import the data entries as normal. Again, nothing unusual there. Should all be familiar to anybody, that's familiar with doing DesignPH work. So once you have that done and you now have everything into your easyPH file, you're now in a position to begin working through some of the basic stuff here in it. So you'll see within easyPH there's only 8 tabs in. So that's all you're required to fill out here for your assessment. So the regular tabs you have to fill out, you fill out your U values tab. So again, I'm not going to go into big detail on it. It's not necessary. It's the same as for any other modeling exercise. So you put in all your build-ups for your various things, for your walls, your roofs, your floors, etc. All that good stuff all gets loaded in. And you set out all the build-ups and put in if you have any like rafters, joists, or whatever. You account for all those as normal. There should be nothing unusual there for most people. So you then have to fill out your areas tab. Now we have to be a little bit careful here with the areas tab, that there's one step that you need to carry out manually, and this is due to the nature of easyPH within and DesignPH. You need to cross-link your TFA from your easyPH tab. So within your easyPH tab, we can have a look at the TFA section here. There's a secondary calculation over on the right hand side that allows us to calculate our TFA. So within that, you'll see we have the gross area, and then we have the TFA value here in red. So what we need to do is we need to go to our areas tab, click on that, and cross-link that value across from that tab. Okay. For anybody not totally familiar with Excel, you can just hit equals within that, click on the easyPH tab, click on the value for, in this case, 189, and hit return. And that will now cross-link in that value for you. So that's the one manual step you have to carry out. Otherwise, all your areas, etc., are all brought in automatically. If you've measured your thermal bridges, they'll be brought in automatically. And then you need to assign the various bits from the drop-down list all as normal. Again, nothing unusual here in this for most people. If you have PV on the building, you must input the projected building footprint. You can measure that in DesignPH if you wish. That's perfectly fine to do so. And you can just input the value there for that into your areas tab. But that's I suppose the basic import process. Again, should be 99% the same for most people carrying out these calculations in regular PHPPs. When you've that bit completed, then we have to go into our components tab, input things like our windows, like our heat pumps, etc. So we can click on our glazing, input that. We can then scroll across and put in our window frames again, all as normal. There should be nothing unusual there. Insulation, thermal bridges, etc. Put in your heat pumps, etc. from here as well. Should be all familiar to most people. Shouldn't be anything unusual. Same with your Windows tab. You input all your windows into your Windows tab as normal. You can put in your transoms, your mullions, fixed sections, opening sections, all that. Again, all fairly all standard inputs. There's nothing really unusual in any of this for most people. Same with your shading tab. In this case, you can see here the shading has actually been manually calculated without the import. But if you have your import, you'll be familiar with these two percentages. Again, they're brought in automatically from the PHPP. There should be nothing unusual there in that either for most people. So that'll put in those inputs, and you've essentially got nothing more to do with those at that point. You just load them in, and that's the modeling process, up to speed at that point. So I suppose once we've got that far, then I suppose we can begin to start working down through the easyPH, and begin to start loading in, I suppose, some of the key data in here. So I suppose the first thing we have to be mindful of here is there are 4 columns here on the left hand side for the main examination and final examination. So your main examination being your design stage assurance, and your final examination being your final certification. So there's boxes here for the designer and the certifier to click on. So you'll see within that it gives you 3 options. There's an X to mean not completed. There's a little timer, a little bell to show that the work is ready for review. And once it's accepted and completed, then by either side, then you can hit the tick on it, and that will tick it off to say it's completed. So that's the process for that end of it. If you're obviously not certifying, then it doesn't really matter at that point. If you are certifying, then it becomes an important part of the process for certifier and designer. So I suppose we start with the project setting. I think that's the kind of the natural starting point here. So within this, we have 2 options here. We can either certify the building as passive house or PHI low energy building. Traditionally, the PHI low energy building is not used all that much. It tends to be kind of more reserved for maybe passive houses that have struggled to meet passive house. It's sometimes used as a stepping stone for projects which may be uneconomical to go passive house, but they do want to demonstrate much improved levels of air tightness, higher levels of comfort, etc., things like that. So you probably know here there's no EnerFit in this, so easyPH is not currently used for EnerFit assessments. So if you're carrying out an EnerFit assessment, you must use the full PHPP. Now, I do want to preface this saying there are many retrofit buildings out there which are certified to passive house, same as Barry's house was a retrofit that was certified to passive house. So if you're certifying a retrofit to passive house, you can use easyPH. It's the standard that's critical here, not whether the building is new or retrofitted. That doesn't really come into it here. It's the standard you're working with that's important. So within that, then we need to select our class here. So 99% of projects will be certified to Classic, so you'll select Classic from your drop-down list. You can also select Plus from that list. You will note that Premium is not on this list. PHI have made a conscious decision to insist that projects been certified to Premium go through the normal certification approach. And to be fair, given the very, very high level that you have to go to get Premium on a dwelling, it's reasonable that easyPH is not really a suitable method for properly assessing them. So you can do Classic or Plus here, at your leisure. There's also then Classic with a non-renewable PE that's rarely used, certainly in the context of Ireland anyway. But majority of projects will be Classic, so that's a standard input. So also to put in the number of dwelling units. You can only put 1 or 2 dwellings in here. So easyPH is currently only valid for use with a maximum of 2 dwellings. We have to be a little bit careful here because when they talk about 2 dwellings, it's 2 dwellings, but a maximum of 1 number ventilation system. So if you have a pair of semi-detached houses, you cannot, with individual ventilation systems, you cannot use easyPH to certify those as a single certified building. Now you could use them maybe to certify them as individual houses, that would be a matter for yourself. But as regards certifying the two of them together, that's not the case. I suppose the second dwelling allows for maybe a case like where you have maybe a granny flat, or maybe a small little attached section of a house that has the same ventilation system, and therefore could easily be returned back to a single dwelling upon there no longer being a need for a second dwelling. So that is the reasoning for that. So your number of dwelling units in most cases will be one. Just bear with me there for 1 second, guys. My apologies for that. So the next thing we have to do then is we have to take a look at the construction method. So in the construction method here, we have a couple of options. We have a lightweight, a mixed construction, or a solid construction. So I suppose this is in relation to our thermal mass. And we don't need to go into massive detail here. We kind of just need to exercise kind of just a little bit of judgment on it. There's no need to provide calculations, anything like that. Totally not necessary. You just nearly, if you have a solid ground floor and you have blockwork external walls or whatever, we'd say lightweight internal partitions, you might put it in as mixed construction. If it's fully timber framed on say suspended timber floors, you put it in as lightweight. If the house is all concrete internal walls, concrete intermediate floors, etc., very heavyweight, you might put that in as solid construction. So again, you just need to kind of agree this with your certifier, but in most cases it's mixed construction captures most cases in Ireland. Probably the notable exception there maybe is ICF, in the sense that while it has a solid concrete core, you do have an inner layer of plasterboard and EPS. So that would be classified probably as lightweight, except maybe where you have a solid concrete floor, maybe a concrete intermediate floor, you might put it in as mixed construction. So there can be kind of borderline cases there. Again, if you're in doubt, consult with your certifier. It's not going to have a massive effect on the results, but it could be the difference between passing and failing if the margins are tight on the project. So no calculations, just it can be done separately. If a calculation was required, the certifier can talk to you about it. So the year of construction is pretty straightforward. Just put the year in. There's nothing unusual there. The building location then, so you're required to put the building location, the altitude in to make sure you get the correct weather file. It's important to note that with easyPH that you cannot use non-standard weather files. So if you're using, say, an adjusted weather file or something like that in a full PHPP and you've agreed that with your certifier, that won't be acceptable for easyPH. You must use from the list of weather files based on your location. So in this case, I looked up Google Maps, looked up the location of Barry's house, and it gave me the latitude as 54.27 and the longitude then is -7.03. I was also able to look up the altitude from the drawings, and that was 71 meters. So that carries out this calculation on the right hand side. Again, Manny will be familiar with this from the main PHPP, and you can pick your weather file from here. Now it does say that Belfast Aldergrove is the closest weather file. You are absolutely free to use a weather file from another jurisdiction. So just say you were close to the border or something like that, and you wanted to use a weather file from one side or the other, that makes no difference. There's no issue with using weather files from different jurisdictions. It doesn't create any issue from Passive House point of view. So like we could absolutely put the Belfast weather file in here. The project's obviously located in the Republic, but it's the weather file is classified in as Northern Ireland for the purposes of that or whatever. No issues with any of that. So I suppose don't ever be in doubt if you're concerned about that aspect of it. So we've used a thinner weather file here. So we've got obviously the various options. We can pick the closest here. You could look at your location and see what's the best weather file to use. Again, if you're in doubt, consult with your certifier on that front. So I suppose once you've all that stuff loaded in, then and that stuff agreed, you're in a good place now to begin the actual modeling process proper now. So as we discussed, the U values and insulation is all put in the U values tab. nothing unusual there. Treated floor area. Now, as I said, the treated floor area must be calculated in this file. So that's stated quite clearly. You'll see here in this section that must be calculated separately here. So use the secondary calculation on the right-hand side. So that's what you're required to do. You can't bring in the TFA from DesignPH. And again, that's a deliberate decision by PHI. I suppose they want to calculate it out so they can, that's possible for to see where the calculation came from and how that was measured out. So that's what's done here. So we'll take a look at how that calculation process works here. So again, for most of you, this should be familiar and should be straightforward enough. So we can put in the various rooms. We can set up our floor levels up the top here. So we can put first, second, third, whatever, you know, it doesn't matter. There's no actual limit here. If we need extra lines, they can be added in. There's no problem there. But you know, in most cases it'll be one to three floors to catch most buildings anyway. So the first thing we do is calculate the gross floor area. So we just load in all our you know, all our room areas in here, and select our level from our drop down list then based on the above. Select the numbering that we have. So if we've multiple rooms in a house that are the same dimensions, we can just use a multiplier function here, you know, for example, say you have 3 bedrooms that are the same, you can just put 3 number in to capture that. There's no issue with doing that. That's perfectly acceptable. So you have 2 choices here when you're calculating. You can actually put the width and length of the room in manually, or you can put in just load it in as an additional area. Now you can use both. There's no problem with using a mix of calculations. It could get a little bit messy doing that, so I would tend to kind of suggest that people use one or the other, you know, but it doesn't make any difference. There's no regulation or anything or any requirement there, so you can use whichever approach you wish. There is also a deduction area, so if you have, say, a column in a room or something like that, you want to take out the floor area, you can actually remove that in the deduction area here. So just say in your kitchen you had just say 1 square meter of a column, you can take that column out by just typing in what the dimension of that is or whatever. So it gives you the option there to correct your value. So again, should be familiar to most people from the standard PHPP. And that I suppose sets the tone then for calculating the TFA. So as we scroll across, we can see there's an actual section here for TFA, and PHI have actually set out the different room types typically that occur in a dwelling, and they've already assigned the factors here that go with those. So that should make it a lot easier for people carrying out modeling, anybody carrying out modeling on or using easyPH. So what we have to do is just select from the drop down list what our room type is, reference from above. In most cases, we'll have living areas with auxiliary rooms and circulation. Where it says circulation here, and that's all circulation within the dwelling. So you'll see there's a separate section here for circulation areas outside the dwelling. That would typically only apply to maybe apartments or, you know, buildings with shared access or something like that. You know, where there's a separate circulation area. It would rarely arise in a single dwelling, certainly in my experience anyway, that you would have such a situation. You will nearly capture all scenarios under the living areas with auxiliary rooms and circulation. So that's, I suppose, for the purposes of PHPP, as most you're familiar with, auxiliary rooms includes utilities, plant rooms, you know, hot presses, all these kind of spaces are all considered auxiliary rooms, and they're considered at 100%. There's no differences there. That's all standard. The one exception there is a tech room outside the dwelling. So if say you had a plant room that was maybe accessed from outside or something like that, you know, we've all seen them over the years where there's an external boiler house or something like that. That might be picked up as a tech room outside the dwelling, but if it's inside the dwelling, it's treated as a living area. You also then can put your stairs or elevator in. Of course, elevators and lifts are rarities in single dwellings, but not unheard of, but a rarity. But you will obviously have stairs in most dwellings. Shafts and voids then, can decide yourselves to put those in. Those spaces go in at as normal in, and you can select their type and then balcony or terrace. So if you're measuring a balcony or terrace, you would typically classify that as 0. So you may just omit that from the calculation. It's a category I would rarely use in certainly modeling day to day. So I say the living areas with auxiliary rooms catches most of them, with the exception of your stairs and elevators. So they'll capture the rest. So you just assign those, within the easyPH sheet. Then I suppose the second thing we have to look at then is, do we have any clear height factors to apply? So I suppose if you have an area under a stairs or something like that that's between 1 and 2 meters high, we need to reduce it by 50%. We can type in the factor to reflect that, or we can put it in a 0 if it doesn't apply if it's below 1 meter. So you just simply type in 0.5. So just for argument's sake, say you have a room there, we'll just say one of your entrance halls or something like that. You have space between 1 and 2 meters high. When you put in your 0.5 to correct it, it will automatically adjust the TFA to accurately calculate it. If there's no adjustment, you just leave that blank. So for most cases, you won't have anything to load in there. If you do, you can put in the correction factor. So I hope all that makes sense so far to everybody. So the next thing we do is we take a look then at our Vn50. So this is a very important calculation because it decides on how stringent our air tightness is. And again, the rules are exactly the same for easyPH as they are for regular PHVP. There's no difference in the rules. The only difference here is how we load in the value. So we can select then our value here for whether we want to include the factor for Vn50. So if you have something like a shaft or a void that you may not be including in your Vn50, then you can set that to 0. For most spaces, you will treat them as within the Vn50. So say normal rules apply here. You take out your internal walls, you take out your intermediate floors. You don't have to correct for your reveals and stuff like that around windows and stuff. There is a little bit of guidance given down the bottom here of stuff that you can just pick up as part of it. So you can include your plaster layer if you wish. You can include joists, and that, I suppose, that's not joists as in joists that are enclosed between two layers of between a floorboard and plasterboards. That's exposed joists. So if you have like downstand joists or beams or something like that, that's not affected. Your flight of stairs is excluded from it, so you treat that as if there's no stairs there for the purposes of volume, etc. So again, all fairly standard measurements. There's nothing should be unusual here for calculating that factor. So I think for most people, you'll find that'll cover most things on it. So I suppose the last thing we're going to look at today then is to go into a little bit more depth on the air tightness test. And this is a banana skin, I suppose, that could catch a lot of people out. So I suppose we'll put a few minutes into that before we start a Q&A, and we can clear up any questions. Again, for your building elements, thermal bridges, windows, etc., window frames, glazing, are all loaded in as normal into the sheets. There's nothing here that should be unusual for anybody. It's all standard modeling. I suppose the standard mantra is, if you're in doubt, check with your certifier. If you're certifying the building, if you're any aspect of it, that runs a risk of upsetting certification, you better check it out and find that you don't have any unforeseen banana skins occurring there. So I suppose then when we get down into the more depths of it here, you might just say, sure, there's only a single input there, Shane. You'll be done in 5 minutes and we can all go and have our lunch. Yes and no is the answer there. Yes, there is only a single input. However, many of us will have found, particularly anybody who's worked at any kind of certification or maybe is involved in a lot of certified buildings, will actually find that often the Vn50 and the volume that's provided on the certificate for the air pressure test often don't match, and that's a problem, but not a problem, if that makes sense. So I'll show you why that's the case here. So to make life a little bit easier, PHI have provided a secondary calculation for us here. Now I know it actually when this first came out that actually the calculation was actually switched backwards. So if you look at the formula in this here, that actually that formula in your in your standard PHP file that you get, you know, in your license package, will actually have that formula switch. So you actually have to put it the correct way to get it to work out the correct value for your Vn50. So what you need to do is find out what's the meters cubed per hour from the air pressure test based on your pressurization, depressurization value, and you'll find that will normally be given in the report. And if they give you the two values, then you just average them. So in this case, it was 308 was the tested value for Barry's house. So the actual volume that was given on the report was considerably more, which actually made the result look much better, because it looked like you had the same amount of air movement or air leaving the house, but against a bigger volume, which meant you were going to have a lower N50 value. So we can actually correct the N50 value in this little side calculator, which actually allows us to get a much more accurate result. So what all you simply have to do is just plug in that meters cubed per hour value, which is, say in this case was 308. That will then divide it by the Vn50 and give you the final N50 value. And what I've done in this case is I've just simply cross-linked that value across to that auxiliary calculation. Now, if it so happens that, you know, and this is often the case, that the volume on the report and the volume in the PHP are the same, then there's nothing to see. Just plug in the value as is. There's no further issues with that. So I suppose that's I suppose an overview of our, you know, of those functions. If anyone has any questions there in I see there's a couple in the Q&A. And we'll work through them incrementally, and feel free to jump in here, guys. Like, there's no such thing as a stupid question. There's, you know, the only stupid question is the one you don't ask. So totally feel free to jump in at any time with a question. So I suppose the first one there is from Tom Bailey, and Tom has asked, you say that easyPH doesn't allow TFA to be calculated via DesignPH. I wonder why exactly, when it's a more easy and simplified approach. That's a very good question, Tom, and the reasoning for that, it was very clearly laid out by PHI, in that they want the TFA to be documented within the easyPH software. Also, when you plug in the TFA values here, it also then allows you to calculate the ventilation rates, which we'll go into in another session here. So you can see here that actually all your ventilation stuff is all calculated in easyPH. So I suppose PHI had a little bit of a dilemma here. Do they stick with the traditional approach of doing it in DesignPH, or do they go with a manually calculated approach? And they decided to go with the manually calculated approach. Now, you are free to measure it out in DesignPH and just plug in the measurements from that. That's what I've done on a good few easyPHs lately, and to be honest, it didn't take very long. So I found that to be the quickest and easiest way. But you can't just simply measure it in DesignPH, assign it as 100% TFA, and then just bring it in with the export. That's actually not permitted under the easyPH approach. So that's hopefully explains that. If you want to add anything else further to that, Tom, feel free there. We also then have another question from another attendee. So they say, hi, I'm interested in using the approach in my projects in India. In what ways can I influence Indian clients to approve this? Well, the good news is there that easyPH is approved for worldwide use. So you're absolutely free to use easyPH in all four corners of the globe. Say, you know, you can use it anywhere you want, all 7 continents. There's no limits on where that can be used. So you know, if your clients in India decide they want to go this way, then they're perfectly free to do so. I suppose I'm not totally familiar with the climate in you, but I'm guessing it's probably in a lot of parts probably hot and humid. So you probably have more of a cooling approach to worry about in India rather than a heating approach. easyPH is perfectly capable of calculating cooling effectively, and accurately working out the criteria requirements there. If you have mechanical cooling in your building, there's no issue accounting for that. There's a whole section here within easyPH that actually allows you to input cooling there, so you can switch on your mechanical cooling. You have multiple ways of meeting your efficiency calculation requirements. You can do a simplified approach. There's a detailed approach, etc. You can put in dehumidification, all that good stuff. So from that perspective, I don't see any issue here. I suppose that the selling point here for I suppose when you go to talk to your clients is that I suppose easyPH reduces the paperwork burden here, where traditionally we have to provide, a big pile of paperwork has to be provided for passive house. And Barry, having been through this process, knows bloody well what paperwork has to be provided. So yeah, it just reduces that burden. And our final workshop, we'll go through the intricacies of what paperwork has to be provided for easyPH and how that is just like chalk and cheese compared to the traditional approach. So I hope that answers your question on that front. So the final question I have here now is from Alan Ritchie. So apologies if you explained this already, but can you use easyPH for multi-house type developments? In theory, you can, Alan, but you would have to do semi-Ds as two individual PHPPs. That's very possible. You would treat the party wall as having no heat loss across it, and then you would model the rest of the dwelling then as a single dwelling and certify it as such. I'm not sure if PHI have fully, how I suppose where they see the limit of that occurring. But I suppose in theory, I don't see why not. I know generally for multi-house type developments, you would tend to follow the standard approach, because you will tend to have the information available to get a much more accurate model. Plus, I suppose it's important to bear in mind that easyPH, there's a slight penalty here on the heat and demand and the heat and load. By simplifying the approach means that certain things have to be defaulted or standardized. So that means that it tends to err on the side of caution. Whereas with a full PHPP, you generally tend to get maybe something in the order of maybe between 0.2 and maybe 1 kilowatt hour less on your space heat demand, and maybe something in the order of the same between 0.2 and 1 watt per meter squared on your space heating load. So yeah, I don't see why not, but I would tend to steer multi-house type developments towards the standard approach, just because I think it makes more sense and it allows the block approach, which is, if you've a terrace of say 6 or 7 dwellings in a terrace, you don't have to do 6 or 7 individual PHPPs, where with the normal approach you can just do one PHPP and they're all done. So I hope that answers your question. I know it's a bit of a gray area, so it's not a case by case thing, I think, rather than a blanket approach.
Thanks, Shane, for that. You've comprehensively answered the questions in the text. Again, if there is anybody there with any burning questions, do come in. And while maybe you're considering that, I'll ask one or two of my own, Shane, if you're okay for that.
Feel free. Absolutely, Barry. Fire away.
Yeah, so the first one is really the demand for Passive House Easy. Are you seeing much of a demand there in Mossart with this since it became live? I know you've been using it in a trial period for the best part of a year, but you're starting to see demand coming through from the marketplace.
We certainly are, Barry. We've had a good few inquiries lately from clients for who easyPH would be an ideal approach for them, and just make their lives a hell of a lot easier. So definitely there's interest in it. I think it's probably still in its infancy, but definitely commercially we're starting to see a good few inquiries for easyPH. And I suppose one of the things that a lot of people find hard to comprehend is the cost of certification. like going the standard road for certification. There's a huge amount of work in it for us as certifiers. We have to go through vast reams of data. We have to go through a lot of drawings. We have to go through a lot of various pieces of information, and it's super time consuming, and it's actually one of the areas where we find that even though our find fees are on the higher are high relative to the budgets of the building, it actually we struggle commercially to make them stack up.
Mm.
Whereas we actually find with easyPH, it will be possible to certify buildings for a fraction of the cost, and commercially for us, it's a better offering as well. So like
Mm.
it will reduce our workload probably by I reckon something in the order of maybe 60 to 80%.
Yeah.
Which means then that there's quite a considerable reduction on the fee, to reflect that, and it's commercially more palatable for us. So yeah, I suppose we're seeing that starting to happen now in the market. We're seeing, the few fee proposals we've issued, clients are much happier with them because obviously it's a hell of a lot less cost for them,
Yeah.
and a lot less burden. There's a lot less toing and froing and tic-tacking and,
Yeah.
couple of meetings, bit of modeling, get the DesignPH done, a few bits, and you're usually there fairly quickly.
Yeah, that's what I was hoping you would go on to say, Shane.
Mm.
And now I had a follow-up question which was around that. So,
Mm.
but for everyone on the call, you've heard it here first. It does mean that certification is that little bit more affordable.
Considerably cheaper.
Yeah,
Considerably cheaper, yeah.
that's good as well. And then I have one final question from me on it. It's around, and I think you touched on this in the first session around thermal modeling. Whenever I
Yes.
went to do my certification, it sort
Mm.
of even though I was quite established in the passive house community, it was new learning to me to understand that you don't have to thermally model every single detail in the
Correct.
building. And now that we PH easy, what's the status with that, Shane?
Well, the rules are largely the same,
Mm.
Barry, as regards, when modeling is required or not. I suppose if you're starting out on a journey, building your own dwelling, it makes sense to try and design it to be thermal bridge free in the first instance. Now, I suppose the definition of thermal bridge free is generally considered a psi value of less than 0.01 watts per meter Kelvin. In reality, I suppose what we're looking at as certifiers is to see, is there continuity of insulation? That's the first thing. Have you put in your thermal blocks around the bottom where your wall meets your floor? Have you got good continuity where your wall meets your eaves, etc. Have you avoided, I suppose, the big banana skins on thermal bridging? Essentially, I suppose if you've done all that and tried to show that, look, I've got a good overall package here, then there won't be any thermal bridge modeling required.
Mhm.
And for many dwellings, that's the reality. If they're designed correct from day one, modeling is unnecessary. If you get to, a very complex set of junctions where you've got, metal SFS, got a lot of maybe things, a lot of junctions meeting where you could have potential thermal bridges arising, it gets a bit more complex in that case. And therefore, then you start getting into requiring thermal modeling, for certainly the troublesome junctions.
Yeah,
Um,
it's really stuff outside of the norm.
it is when you get outside of the norm, it starts to get a bit more tricky. But if the junctions are fundamentally designed well to begin with, and I suppose the key thing here is continuity. That's what we're looking for as certifiers is, have you put arrangements in place to minimize your thermal bridges, say your thermal block where your wall meets your floor, all this kind of stuff, around your windows. Have you got the window position well correctly within the jamb to minimize the thermal bridge? All these kind of things start to come into it. And then the thermal bridge goes out the window then for the modeling. And you just effectively don't account for them in PHPP, because I suppose the test is, would the negatives cancel out the positives on the thermal bridges?
Mm.
And obviously we're looking for negative thermal bridges, and you are still free to model. If you have a load of negatives and you model them and find that they're all negatives, you get the benefit of that in the model. But you know, if you find you have a hell of a lot of positives, then you know you have a bit more of a challenge. So
Yeah.
it's a little bit it's not entirely clear where those lines are exactly drawn, but the general gist is design well in the first place, and you won't have any modeling to do.
Yeah, okay, and it's probably a unique perspective for those that are certifying like yourselves in Mossart. It's you know,
Mm.
really and truly anybody coming to this, we're not advocating that you don't. It's
No,
for
no,
your
of course not.
you know,
No,
it's only for certification. No,
yeah,
well, that's brilliant, Shane. I've enjoyed that.
yeah. I hope it was
Thought it was
helpful
an
for
excellent
everybody.
session. Yeah.
Yeah, yeah,
I suppose just in terms of my hosting of today, it's just really to say thanks to Shane for giving up his lunch to come and share his knowledge with us. And that's not the end of it either. We have another session next Monday, which is the 15th of July. And that's also between 1 and 2, I think, Shane, isn't that right?
that's correct. Yeah.
Yeah.
So the 15th July we'll have the next session, and we have two further sessions then on the 29th of July and the 12th of August as well. So
Uh-huh.
and you can apply through Eventbrite for that. So
Brilliant.
if you go onto Eventbrite and type in Passive House Association of Ireland and online events, you'll find it there. And get your name in the pot for that. So I
Brilliant.
see we do have a few more questions there.
Oh,
So
sorry. Yeah, brilliant.
yeah, we do. And look, if anybody wants to drop off, we're gone over our 45 minutes. If anybody needs to drop off and go and have lunch or whatever, get back to work, feel free. I'm okay for a couple of minutes here. I can run through these questions, and just make sure they're knocked out before anybody heads off.
Yeah, no problem,
So
Shane. You
I,
go
I
for it.
leave it I leave it open to the floor to head off. So I suppose the first question we have there then is to maintain the design intelligence of PHPP, will there be an export function from easyPH to the full pH or to the full PHPP? At the moment, there's not really. We have tested it. We found it to be a little bit clunky. We found the best thing to do is actually to do a standard export from DesignPH, and then just paste in like the window frame details and window glazing stuff and that kind of thing, and then start from there with it. That's been our experience. But at the moment, there's no dedicated export function from easyPH to full PHPP. Um, so then Tom Bailey had another question here. So, in the future, what aspects of easyPH do you see changing or optimizing? Obviously, you've been doing a trial period, you know it well by now. Um, I think in time it'll probably come to capture Enerfit. I think that'll be a big step whenever that comes around. There is currently a single house approach for Enerfit, but it's kind of more geared to apartments rather than dwellings, you know, to standalone dwellings. So I think that'll be probably the next big optimization on it. I think time will tell, you know, from whether uh, I suppose I suppose monitoring results to see if easyPH dwellings are actually performing within their expected parameters. I suppose there's now a known what level passive house or PHPP model buildings run to anyway. So that'll become clear in time. I don't see there being a huge amount of room for change or optimization. Otherwise, I think the standard for easyPH is fairly well set now, and I think you know the only thing we might see change in there is things like weather files, and you know we may see maybe additional classes or subclasses of passive house coming in time. You know that's always a possibility, stuff like that. So I think fundamentally now easyPH is set at its current, you know, as its current approach, and I don't see it radically changing into the future. I think it's fairly well defined as to what needs to be done. So, um, like we've been trialing it for a long time now, or butts of a year working at it, and I think we believe this is a game changer for single family dwellings, no question. It's a total game changer. So I hope that answers your question, Tom. I know it's a bit of a grey area as well. We do our best on it. So I suppose there's two questions here then, rather from a full pH. I might be following on from the previous questions. Does easyPH to address the need determining model every window junction for psi values? I think we slightly dealt with that in the previous question. I suppose for the windows, ideally the windows should be modelled, even if the rest of the building is not modelled. PHI tend to have a preference towards ensuring that the installation thermal bridge is modelled for each building. So we would suggest modelling those just on their own, or using the certified values if it suits. But yeah, if not, if budget is an issue or whatever, then you can put more, put conservative values in, and maybe talk to your certifier and maybe see is there have they something in their library that they might be able to give you that might suit it or whatever. So there's a couple of ways of skinning that cat. You can go at it any which way you want, but it's what you can take from a previous project. You can ask your certifier, you can model it, you can take it from a catalog. There's various ways of doing this. So I think there's no hard and fast need to thermally model every single window junction. I think it'll be on a case by case basis. Be my view there. And then I suppose that follows on from the question above. So, and the final question here is from John Moorhead, a good friend of the office, of our office. Great to see certification streamlined, but concerned there may be a disconnect without the climate and heat demand visuals, graphs, etc. that exist in full PHPP. It may lose PHPP function as a design tool. That's a very good point, John, that you've raised there. And I would actually agree that there are very good graphs in PHPP that actually calculate the space heat demand. You can unhide the tabs for annual heating and heating load. You can unhide those and take a look at the graphs, and those, they are actually based on those graphs, so they are still accessible there. But I'd agree with you, they're not actually directly visible in PHPP. So there might be a little bit of room there for PHI maybe to add some add some graphs into the easyPH tab, just to be able to set out, I suppose, where it's getting all its calculations from. But actually that is a very good point, and I will raise that with PHI the next time I'm talking to them about PHPP. So, but yeah, it's a good point.
Thanks again, Shane. No, I think that's us.
Very welcome.
We're up on 53 minutes there, so
yeah, I think it's fantastic. Time to call a halt to it. So yeah,
not a problem. No, but again, look, we're back next Monday, the 15th, between 1 and 2. So thanks everybody for coming.
Yeah, thank you everyone. Bye bye.
Cheers.